Hey, what's going on, guys? CodeMonkey here. After successful passing of the perf test, we're now actually ready to go and make our chess engine making some moves, basically, and playing chess. But in order to make this process a little bit more comfortable, I would like first to provide some very basic interaction with the GUI in order to being able to see the process of how the engine actually plays itself within the GUI. And in order to make this possible, I'm not going to be writing the full-blown UCI protocol just right at the moment, but I just want to provide, well, at least in this video, we're going to be writing the parse move function, serving the purpose of parsing the either user move string or the move string provided by the GUI when it interacts with your chess engine. So it would be sending you like the moves that should get parsed within your engine, and and then you need to make those moves in order to adjust the position to search the best move for. So we'll first provide just a few very basic UCI commands in order to establish the stable interaction between our chess engine and the GUI, and later on when we would involve some timing within our chess engine, it would be really later on, not just in the next few videos. So we'll then well, actually when the search and evaluation will be brought to some sort of release state, let's say, so not kind of the state when it's done, because like chess engine development never ends, but at least at the state when it would be at the state of, say, like the first version of Bitboard CHESS ENGINE is about to come out. In that case, we'll come back to our UCI implementation and make it better, so it would also fit some timings, not only fixed depth search. But first we'll implement just the bare fixed depth search in order to actually being able to interact. And again, like before, we don't have things like move ordering and some search optimizations. There is no much need for whatever timings, because it would be slow before it gets better, basically. So we really need so first it's literally enough just the fixed depth search only for the debugging purposes. I'm not talking about the release, obviously. So just for the debugging purposes, it would be literally enough to have only the fixed depth search, and it would even be able to play versus other engines for those who is tempted to make this as soon as possible, basically. But again, like just like I was already saying, we will definitely make UCI interaction involving various timings as well, to make it play blitz and longer time controls, things like that. But anyway, the next few videos would be taken in order to establish this very basic interaction, and then we'll go implementing our evaluation and search, and this would give us an opportunity to watch how the engine's strength and style of play are growing, like how this strength is growing, how the style of play is changing already within the GUI. So the visual representation of its changes is more appropriate in my own opinion. So the way I usually do is actually first try to provide this very basic UCI interaction, and then go for implementing the search. So bearing this in mind, let's start implementing the very first function that would be involved within the UCI loop and all the logic that regards to the UCI protocol connection between the chess engine and the GUI, called the parse move. So this would be the integer function, and let's call this simply like parse move. So we make it integer because it would be returning either true if the move is available, is legal in this position, and false if the move is illegal. And it would be taking the character pointer to the move string, like this. And here we say parse, let's say either user or GUI input, move string input, and let's say an example like e7, e8, queen. So this like moves So I call move string, I call this like strings to be the move strings. So this is the exact input that either GUI, or if you try to mimic the GUI, you would be doing this by hands within the console. So this is the string that would be testing our move, our parse move function with. Okay, so the next trick. So the very first thing to do here, we need to create a move list instance, and we need to generate the moves. So the idea is quite pretty simple. So I just grab these 2 lines of code here. The idea is very simple. So we could have actually make we could have just parse this string and make it on board, but let's say the move is a pawn promotion, or let's say the move is an peasant capture or a double pawn push. In this case, we need to alter the board state appropriately, and in order to do this, we also need to pass the appropriate flags into the make move function. So in order to avoid doing this manually and manually creating all the logic, handling all the stuff that we've been doing with the make move function, we can simply generate the moves and then just try to compare from square, target square, and promoted piece, if available, with the move within our move list. And in case if it matches, that means that the move is legal and we return this move, and then the move that we've returned from the move list of generated moves already contains all the appropriate flags being set, and we can just make this move on board in order to alter the position of the inner chess engine's chessboard representation. And I will say a few words regarding some specifics of the UCI protocol interaction compared to, say, WinBoard or Xboard protocols a bit later on when it comes to the particular implementation of the UCI commands. So not just right at the moment. Okay, and now we need actually to parse our moves. So let's start with parsing from squares. So parse target square, and let's create the integer called, oh sorry, not the target, let's parse source square obviously first. Source square. So by saying source square, I'm in this part. So first 2 elements, first 2 characters within the move string, and assuming that we actually pass in this pointer to the move string, we can reference the elements within this pointer just using the indexing, like as if it was an array, and we just try to index that array. So the index of E letter would be 0, this index would be 1, 2, 3, and this would be 4 if available. So let's create the variable called the source square, and it would be equal to move string indexed by 0, so this element. And now in order to convert this ASCII characters to some sort of a numeric values, we can do these tricks like -a character. And this entire expression we want now say plus, and now it's a little trick is involved here. So we need to say 8 minus because of the current particular board indianis we're having here. So if we have a1 here, we don't need to say 8 minus, but assuming this, so just like we've been doing when we were printing the ranks within our print board function here. So we needed to say like 8 minus to print the ranks actually. So this is the same idea here, and here we need to say move string, and now we're referencing the index of 1, which means like this sort of an element, and minus 0 ASCII character, and also this part should be multiplied by 8, which is the width of the chessboard. So like we actually looking for searching for a square, so we say like rank multiplied by 8 plus file, but here we just first parse in the file and then we parse in the rank. That's it. So if I did everything correctly, it should now be transforming this like coordinates to a particular square on chessboard. So we'll now just go and test this. So let's try and print. So first, well, we can actually go for, let's say source square and string identifier, and already use our square to coordinates indexed by source square, and this should be working. Okay, so let's now open the terminal in the current working directory by typing make debug. I just want to build the source, and if it can pass on run the BBC binary executable. Okay, and oh my god, it would be running the perf test now. Yeah, we don't really need that, so let's avoid going for perf test in here. Yeah, actually I forgot to kick this away from the perf test. We didn't really need this line, but it doesn't matter really. So let's drop it like this. Okay, and I just want to call our parse move. Parse move string, and I'm not going to be using user input at the moment. I would just be using the precoded string, but the idea is absolutely the same, so no matter basically. So we can simply say like print, parse move, parse move, right? Not move string, yeah, parse move, and we need to pass the move string. Well, let's say it would be e2, e4, and now it should print the square e2. So it would first convert the e2 square to some integer representation of the e2 square, and then it would index the square to coordinates array by that index to get the human readable coordinate. So it should print e2. Okay, and it does print e2. So just to give you an idea again, so if we just print this in a decimal representation, then let's say this source square, so it would be just printing the number that is 52. So we have a look at our board layout. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 16, 16 plus 8. I'm not good in math. So 52 is just right over here. So E2 has the index of 52. That's the trick. We're just converting this to this human readable coordinate using this index by this sort squared coordinates array. So quite pretty easy, I hope. Okay, and now let's go. So I don't really need this anymore, and now let's try to do the same but for the target square. So let's go to target square now, target square, and I just want to grab this entire line, and here we would be having the target square, and I'm using the index of 2, which would be pointing to this element, the third element, and here the index of 3, which would be pointing to this element, not yet to the promoted piece if available, which is important. So now it should print E4. Okay, let's have a look. So source square, target square is still E2. Okay, what's going wrong here? Okay, so I just didn't. I'm indexing the square to coordinates by source square still. So let's index this by the target square like this. Okay, should be 4 now. Okay, perfect. Okay, and also we need to initialize the promoted piece. So first let's say parse target square, and here we want to initialize promoted piece. So at the moment integer promoted piece would be equal to 0, and now the trick would be to loop over the moves within a move list, just like we've been doing in our perf test. So I can simply say like for integer move count equals to 0, move count is less than move list move count, move list count, just like this, and move count plus plus. Okay. Now, just for simplicity, we can initialize our move. So let's create the integer move that would be equal to move list moves indexed by move count, like this. And now the condition. So the idea is to make sure the source and target squares are available within the generated move. So in code, this would be in following. This would be look like the following way. So we can simply say like if, and now we're using our source square, which is an integer, okay? And we say if source square is equal to get move source macro that is extracting the from square from the move, and I'm using the move as an argument here. So we're looping over all the moves within our move list, picking up every single move and trying to extract the from square, the source square from that move. And if that square would be exactly the same as the source square parsed by the user input, then we make sure that this is actually available. But also at the same time, obviously, we need to make sure that the target square equals to get move target, and move like this. So in this case, so now we make sure that the source square and the target square are actually available within this sort of a move list. And the next difference might be it might either contain the promoted piece, or it might not contain the promoted piece. So now we actually need to initialize the promoted piece. Well, here let's actually say not initialize but define promoted piece, and here we want to initialize promoted piece. So we can simply say like, or hold on a sec, probably we don't even need to create this here, I guess. I think we can get rid of this. Yeah, we can just, it doesn't involve any performance slowdown, so we can just make it here, I guess. So in promoted piece, it would be equal to get move promoted. Okay, and move. Now let me just try to compile and run this to make sure it still works and no errors. Okay, perfect. And now there would be two options. So it might not contain promoted piece, and in this case, but it may still contain the source square and the target square, and this is already the condition to return the value of true to make sure that the move is actually legal. So here we just want to return a legal move, and we can simply say return 1, which means it's true, it's legal move. And by default here we want to say just return illegal move, which means that if we didn't pick up any move within the move list being generated to check up this, then we know that this particular source and target square taken from the user input are not do not belong to any legal moves, and that's the reason why we're returning 0. So if we ever get here, if we just pass this loop and ever get here, we would be returning 0. But otherwise, if we find something within this loop, we would be returning true. And one last thing, we need to make sure that we also return legal moves in case of pawn promotions. So I'll provide the commentaries later. So let's say if, and now we're comparing our promoted piece with if it equals to either, well, let's start with queen, basically, like this, or promoted piece equals to black queen, and at the same time, and now we're referencing the move string indexed by 4, which would be pointing here. So we say if move string indexed by 4 is equal queen, it would be always lowercase. In this case, we just want to return legal move. So return legal move, and we just say return move here. And yeah, sorry, so not one but move, because we actually want to return the move that we would be making on our chessboard. That's kind of it. That's the idea. I just used one to make sure that it is true, but it would be true, but it would be the move. So because we can't make one on the board, we can make the encoded move. That's the idea. Okay, and now we need to do the same for all the other pieces. So else if, and promoted piece, well, actually let me grab this entire stuff here and just say, like, so if promoted piece equals to either white rook or black rook, and the move string equals to R, in this case we also want to return the legal move. Well, actually I can grab the entire stuff here, copy. Now the same the same for bishop. Okay, and the same for knight. So white knight, black knight, and move string also knight here. Okay, so let's now provide some commentaries. So let's say promoted to queen, promoted to rook, and here promoted to bishop, and finally promoted to knight. Okay, so I'm just, oh, hold on a sec, guys. I just hold on, I just misplaced this move, or no, hold on a sec. Oh, I just missed one little thing here. So we need to make sure to check all this stuff only in case if promoted piece is available. So so say promoted piece, promoted piece is available. So we can say if promoted piece. So obviously if the promoted piece equals to 0, no need to make all of this checkup. So only in case if it is actually available. So yeah, like this. And also just to make a slight insurance of it won't be parsing some run promotions. Obviously it won't be happening really, but we can also add continue here, so it won't be returning the move for, well, let's say promoted to pawn or to promoted to king or some illegal stuff like that. So I just want to say continue, continue. Oh my god, did I spell this correctly? Yeah, it is correct. So just continue the move, the loop on possible, I don't know how to call this, wrong promotions, I don't know. So so let's say it would be promoted to some number that is not available within this QRBN. Let's say it would be like say an example, E7, E8, and some weird letter that is not, which doesn't make any sense. So if we just don't continue within this loop here, it would return true for this move, right? But because even though we didn't hit any of these cases, it still would return true here. So in order to avoid this, we need to make sure that we continue from the loop if none of this legal promotions is available. Obviously we can drop it because we'll never be using things like, you know, so GUI never never makes mistakes, so it would always be moves like this because we're making them with the mouse, we're not typing them by hand. So it's maybe it's not needed really, but it's not a big deal to write a single continue word, right? So this is it regarding our parse move function, and if I did everything correctly, this now should actually be working. And let's go to, not to the tricky, but let's go first to the initial position, start position. It's called start position, and also let's say move equals and parse move and this move, and now we can say if move is true, which means that it would be there would be some move returned, right? Otherwise it would be just 0. So if move is true, I just want to make move on the chessboard and make move and this move, and otherwise I just want to printf that this move is illegal, so just say illegal move. So just to test this stuff a little bit, so if move is legal, we just want to make it on board, otherwise print error. Okay, so I didn't yet provide the user input, so I would be doing this input within the source code, but just as a proof of concept I want to demonstrate you this. So let's try to run the code again, and now it should be making E2 E4 move, if only, okay, too few arguments to make move, excuse me. Okay, I just forgot to say all moves, so here make move, just say all moves, obviously because we are distinguishing between quiet moves and captures. So now this should be working. Okay, so we got this E2 E4 working, and now let's go to our tricky position, and I just want to make some tests with this tricky position as well. So let's start with a castling moves. So yeah, also by the way, make sure that you see like this impedance square has been set when we moved E2 to E4, even though we didn't specify this obviously within the move string, because move string knows nothing. Okay, just let's say it was like e2, e4. It did know literally nothing about if this is a double pawn push. It's just a string, right? But as far as we did reference our generated moves and stored within this move list, that means that we did provide that double pawn push flag from within our move generator. That's why we did set up this in peasant square properly. Okay, now let's try to castle. Let's say like e1 goes to g1, and it should now castle. Okay, castles and takes the way castling rise from white queen completely. Let's try castle to c1. Okay, the same. Okay, and now let's try simply to move a rook. Let's say a1 goes to b1. Okay. Yeah, so just can castle queen side, but still can castle king side, which is great. So the very last thing, I just want to put this pawn on b7. Okay, so we got this pawn on b7, and let's now try to make b7, b8 queening. So b7, b8 queening. Save. And okay, for some reason it gives an illegal move. Okay, let's try to debug this stuff. So the very first thing to consider, I just want to make sure that promoted piece is available. So let's try to print promoted, and well, let's print this in decimal, it's faster. So promoted piece, save, and let's go. Okay, promoted, hold on a sec. So he should be printing all the promoted pieces. Yeah, so it goes to queen, rook, bishop, and so on. Okay, so now let's try to check. So it should step in here, right? Okay, so I'm just wondering, promoted piece. Oh, okay. So why did I actually make this this characters? No, not like that. Obviously, it should be the constant. So queen like this, and same for the rooks. Yeah, what have I done? Yeah, I'm comparing with the constants, with the integer encodings, not with the characters. I'm comparing with the characters only here. Okay. Yeah. Okay, so now this should be done. Yeah, now it's queening. Okay, so now let's go and try this with rook. It should be working as well. Okay, goes to rook, bishop. Okay, yeah, and knight. And hopefully it would be the same for the black pieces. Well, at least I really hope so. But yeah, we can actually try that as well. And I'm just wondering, so it should give an illegal move in this case. Okay, yeah, it gives an illegal move that I don't specify any piece to promote pawn to. Okay, and now let's make a pawn here. So black pawn, let's move to black pieces, and let's try to move the piece g2 to g1. So g2 to g1 should give an illegal move without specification of the piece to promote. And if we say queen in, it should be black queen now. Okay, and now black rook. Okay, black bishop. Okay, and black knight. Okay, and well, I really hope that in peasant should be working literally the same, but well, okay, let's test the in peasant as well. So white to move. Well, actually, yeah, let me grab this again. So tricky position. And now I just want to alter it to make the in peasant available. So this pawn, erase the pawn on c7, so erase this pawn, and here 2 pawn like this. Have a look. Yeah, and now should be capable of taking on c5. So let's say c4, c5. It should take an in peasant capture now. Excuse me. Oh, sorry. D5. What have I done? D5 to c6. Yes, it's the wrong move. Yeah. So d5 takes to c6. So this should be working now. Excuse me. Hold on a sec. So we have the d5. And it should be taken. Oh, I didn't specify the in peasant square. Yeah, that's the reason why it didn't work. Okay. So now if this is the c6 square is in peasant, it will generate a move respectively. Yeah, now we just take and the pawn is being removed just from the user input, nothing much. Well, okay guys, so I think this is it for this tutorial, and this parse move function is quite pretty important within the entire UCI protocol. We would be using it in order to parse commands like position, start, pause, moves, and then the list of moves to make, and we would be parsing every move and then making them on board in order to adjust the position. And the same for the UCI command position, FEN, moves, literally the same stuff when we're starting not from the starting position but from the particular FEN. Okay, so this should be fairly enough to parse the moves taken from the GUI. Okay guys, so this is it from my side. I hope you learned something interesting out of this tutorial. I hope to see you in the next videos in this series. Until then, and take care. And thanks for watching guys.